So today we take advantage of cofunctions to solve the problem given here. What acute angle theta solves the equation tan theta equals cotangent of theta plus pi over 4. So this is saying there is an angle such that if you take the tangent of that angle, it would be equal to the cotangent of that angle plus pi over 4. And it would be kind of tricky, I think, to guess and check at that one. So I wish it were possible that there were some regular algebra means, inverse operations and such, just to sort of get theta by itself in one shot, but no such luck here. We need some background knowledge, and that background knowledge is the knowledge of cofunctions. And what are cofunctions? Well, I'll give you an example. Cotangent and tangent are cofunctions. Cotangent of something, cotangent of x, anything, will always be equal to the tangent of pi over 2 minus x, pi over 2 minus that thing. To give you an example of why this might be so, let's go back to degree mode and imagine a right triangle. And let's suppose we have an angle x, acute like that, along with side lengths a, b, and c. Clearly, the cotangent of x is going to be adjacent over opposite. So we can write down cotangent of x is b over a. Similarly, we can talk about the other side of the triangle, this thing. Now, because of the triangle sum theorem and 90 degrees being taken up by that, these, of course, must add up to 90 degrees, and this one, whatever x is, would have to be 90 minus x, the complement. And if we investigate the tangent of that, we'll find, traditional SOHCAHTOA definition, opposite over adjacent. So the tangent of 90 minus x is also b over a. Cotangent and tangent are cofunctions. The cotangent and tangent of complements are equal. This works vice versa. I can swap the position of the pi over 2 minus x and the x if I wanted to. And there are two other sets of trigonometric functions that do this. Okay, sine and cosine do this. Secant and cosecant do that as well. And I encourage you to prove that to yourself. So let's use this information to make a convenient substitution. Let's say that tan theta is equal to tangent of pi over 2 minus the stuff over here. Should be valid, right? Because cofunctions say that whatever this is, it would be equal, if the cotangent of it would be equal to the tangent of pi over 2, or 90 degrees, minus that thing. And this is obviously convenient substitution. We can take the arc tangent of both sides and get the following. I should mention, when we take an arctangent, we are asking the question, what angle, what input has this as an output? That's why I've put the tangent graph here to remind you that actually there are several answers, infinite answers in fact, for the arctangent of any input to that function that's defined, okay? And they are all separated by 180 degrees or pi radians. Technically, to be complete here, I'd have to say plus pi n, where n is an integer. However, I don't have to do that in this case, okay? Because as we're going to discover, the first one is the acute angle, the one that's going to be less than pi over 2. So we can kind of gloss over that fact and effectively just equate the arguments of the tan functions. The fact that they asked for the acute angle makes this simple. Now, we should be able to solve for theta by normal means. Theta is equal to pi over 2 minus theta minus pi over 4. Just pardon me while I do some arithmetic here. Algebra, actually. Common denominators for working with pi. 2 theta equals pi over 4, and theta is equal to pi over 8. That's an acute angle. That's less than pi over 2, so it's exactly the one that we're looking for as promised.